Hey guys, welcome back to Bog of All Trades. This here is a TP-Link RE190. And guess what? It does not turn on after only 2 months of usage. And this is not a one-off case. I've had another one of these bought exactly the same time, which went down with the exact same issue. And I've had a WA850RE that also has the same issue. They simply do not go on. Now, you would say I'm with bad luck, but I've seen other people with the same problem. Now, on the package, there is an advertisement of 3 years warranty. So we just wrote to TP-Link. What is this? Can you return it over warranty? Now, it didn't go so smooth. I bought this router off German Amazon. And TP-Link wanted us to ship it to Germany on our costs, and then they would repair it and send it back to us. Shipping to Germany would cost approximately a new router, so I didn't bother. And today I will be showing you how to fix this one over here so it actually works. You will be surprised what the fault is. Bog of all trades. I do everything and more. For this repair, you will indeed need some tools. That'll start with a heat gun, then you'll need some screwdrivers, and in the end, a soldering iron. These are tools most people do have, and they can be purchased for a relatively cheap price. Let's take a look at the access point itself. It does not have any bolts. Well, it does have 2, but those are inside. Other than that, this front panel is glued in, and so we'll need to take it off using a heat gun instead of screwing it off. What a great way to make a non-repairable product. But we'll repair it anyways. Start by taking our heat gun, putting it to low heat, and heat up the edge of the router. Then we try to open it up with a screwdriver. This is not an easy task. I will have to recommend using gloves for this. First, so you don't accidentally burn yourself on the heat gun, and second, to not get the screwdriver in your hand. The glue used in here is very high temperature, and so you'll need a lot of heating to actually get it unlocked. And that is how it looks inside. As you can see, it's fixed on 2 screws, and we'll unscrew them now. Very small screwdriver. We have this black screw over here and this black screw over here. Now, you can still not open it because it's soldered on to these 2 contacts which lead to the plug, and we'll have to unsolder them before we can repair the router. Before we unsolder the contacts, I do want to show you something. If we plug it in we have the LEDs over there, and they're doing the exact same thing that they did before. The parallel LED shines, then blinks, and then, wait for it, all LEDs shine and all turn off. This router is broken. Having the soldering iron heated up, what we will do is remove the solder on these two contacts. These contacts lead directly to the plug, and the board soldered on them cannot be taken out of the router. One contact is out, one to go. There we go. This here is the router board. Now, is there anything peculiar you can see when you look on this side of the board? Nothing? What about this capacitor over here? It's a bit blown. What we're gonna do is we're gonna take it out and put in a new capacitor of the exact same specifications. That is 470 microfarads and 16 volts. The capacitor is soldered on by these two pins over here. What we're gonna do is we're gonna heat it up and desolder the capacitor and put in a new one, a working one. And we see what happens then. And we're done. This is how the board looks after soldering in the capacitor. I used a capacitor from an old TV I found in the trash and disassembled it for electrical components. Soldering the capacitor in was, however, no easy task. The reason for that is that the solder used on this board is of extremely high temperature, and the negative pole of the capacitor is connected to the negative side of the board, which has a very high heat capacity. And my soldering iron was just not powerful enough to solder effectively. But now that we've got it soldered in, we need to solder it in to the casing. What's peculiar about this board is that the solder used to solder it to these contacts over here in the casing is not of high temperature and can be soldered easily. Interesting. The board is also covered with varnish, but this varnish is not over the components, but rather only over the board itself. But it's a really good varnish. It does not get damaged even while soldering. Before we get on with the soldering, just a bit about the board itself. This board runs on two chips. That's the MediaTek MT7613 RE190BEN, that's this chip over here, it is for 5.8 GHz Wi-Fi, and the MediaTek MT7628DBN, which is the 2.4 GHz Wi-Fi chip, and it's also the main CPU of this board, which supports up to 5 Ethernet ports. You heard that correctly. There is none on the board, but there's a small plug over there. And possibly in a later video, we'll be trying to upgrade it to run on an extra Ethernet port and see what happens. I'm actually interested myself. But for now, let's get on with the soldering. The board fits into the main casing like this. And we just gotta solder these two contacts. And that's it. Now, let's plug in the router and see what happens. Power's on. Starting. And it's running. Now, to the faults of the board. Well, first of all, this capacitor is a really bad capacitor. And I'm gonna measure it using my multimeter. We're just gonna put it to capacitor measure. To 84 microfarads out of the supposed 470 microfarads, almost a 50% drop. No wonder the board stopped working. The second fault of this board, which we didn't fix, which they should have fixed, is that on the other side, over the 5.8 GHz chip, as you could see here, there was a certain cage, but the cage itself was not installed, so it was not properly shielded from interference. Bad. But what else could you expect from TP-Link? For now, let's finish this repair. The board has to be screwed in using the 2 bolts we took out. That's it. Just like that. And now we put on the lid. As I said, it is by no means new, and so in the next video we might scrap this casing and try to connect an RG45 LAN port to this router. By the way, this here is the second router, which I was also fixing. And guess what we did? The exact same thing. Over there are the 2 pins we soldered. It's not screwed in, but it's already soldered in, so you can not see it very well. But over there is the same capacitor we soldered into this one, or a very similar one. the capacitor was also blown. So how come TP-Link uses such bad quality parts in their routers, sells them and refuses to return them for warranty? Because you ordered them from a different country? This is a really bad customer service. And how come TP-Link make their routers unrepairable, using glue to seal the outer case on a non-waterproof router? This WPS button will indeed let water through, so the glue is useless. But it prohibits repair by making the router look very ugly after you've opened it. Additionally, using high-temperature solder on their boards will make it even more difficult for a normal person to repair. And that is very bad practice, and I personally condemn it. That is not what we should be doing with our technology. Now, we might play around with these routers and still open WRT on them, put in a new LAN port, but in general, I've been migrating away from TP-Link. And you can see one of these videos over here. In this video, I install a Comfest router instead of my TP-Link router, and we see how far the Comfest router actually gets it. Small secret, it is 1,150 meters of range. I was flabbergasted. So be sure to check that out and subscribe to the channel not to miss out any more router fixes, playing around with these routers and seeing what we can get out of them. Thanks for being with me, and you will see each other next time. Ciao.